All right, hello guys. So today we're doing lead code number 3006, find beautiful indices in the given array. So here we're given a zero index string, string S, a string A, and a string B, and an integer K. An index I is beautiful if the index I is greater than or equal to 0 and less than or equal to s dot length minus a dot length, and s the substring of s from I to I plus a dot length minus 1. So just this substring of s equals a, such that there exists another indice j, such that indice j is in between 0 and inclusive and s dot length minus b dot length, and the same case where there exists some b in the big S, and the absolute value of j minus the two indices is less than or equal to k. So here we have an example. So this string is I saw a squirrel near my squirrel house, oh my. And we have a equals my and b equals squirrel and k is 15. So we see that there's a my whatever indice there is here, 16, I guess, and squirrel is whatever, right? And index 4 to 11 is squirrel. Oh yeah, here. And so 16 minus 4 is 12, and 12 is less than 15, so that works. And the other. Now we have example 2. We have A, B, C, D. A is in there. B is also A. And K is 4. There's one beautiful index at 0, because, 0, and then 0. There exists A and A. And we return the index. Okay. So my initial solution is we have a list called good, and we traverse all of S for the length of the amount of indices. And if we just check these two conditions here, so if I is less than or equal to the length of S minus A, and the substring equals A, and I is greater than or equal to 0, and then we check inside the list for the same condition for B, and if it's not in good, we append it and we return the good. And the issue is that this is a n squared, if not greater solution, because we're looking at the substring. So greater than an n squared solution here, which is really inefficient and does not meet the time complexity we needed. So my second answer was to get the indices of A and the indices of B, and we have our answer where we append our indices into. So we go through um, A, or like S looking for A, and if the substring equals A, then we append the indice into A. Same thing for B, and for indices in A, we go through the indices in B, and if this condition holds, we append it, and then we break because we do not want to double count the indices, right? And the reason we're not using a set is because the indices are sorted from smallest to largest, so a set's unordered. So we wanted to use a list and go in order of the specific indices. So we have the break so we don't double count because there could be repeats, right? And we have the sort. That's kind of unnecessary, but whatever. And we return. Cool beans. And we can run this and submit it. And we passed. Cool beans.